So students, we will start with application of uniform circular motion. In this we will study four types of application. From that, first is vehicle along a horizontal circular track. In this we will consider a vehicle of mass m, which is moving along a curved horizontal road whose mass is m and the weight of the vehicle is acting downward mg, and the normal acting on the vehicle is n. And while moving vehicle, tires of the vehicle and the road surface will have friction, and that frictional force is given by static friction Fs, and this is what the center of the curvature. So now from this diagram we can see that the normal and weight balances each other. Each other means the normal will balance weight mg, and this frictional force provides necessary centripetal force for the vehicle. Now this is equation 1 and this is equation 2. Divide equation 2 by equation 1. So we will get Fs upon n equals to mv square by r into mg. So Fs upon n equals to v square by rg. But from this diagram you can see that the radius of the curvature will remain constant, and therefore the velocity will increase and this frictional force also increases. But this frictional force has upper limit. Means what? If velocity goes increasing, this frictional force will also increase. What? At certain time it comes that frictional force will be constant. So therefore the maximum frictional force. So the maximum frictional force will be mu s into n. And this what mu s is? Mu s is coefficient of static friction. Now from this we can rewrite this equation number 3, that mu s equals to v square. This will be maximum, v square by g. So therefore maximum velocity, square of maximum velocity equals to mu s r g. Therefore taking square root, v max under root mu s r g. Now the second application of uniform circular motion we are going to study is well of depth, means mouth ka core. So the shape of well of depth is like cylindrical. So I have drawn this. Now vehicle is performing circular motion in this well of depth. So in that state the weight of the vehicle act downwards mg, and the frictional force is in upward direction Fs, and the normal reaction is towards the center of this cylinder. Now this frictional force means this normal reaction gives necessary centripetal force, and frictional force will balance the weight of the vehicle. Now we know that Fs equals to mu s into n. This condition can be Fs less than or equal to mu s into n. Means this frictional force cannot be greater than mu s into n, but can be equal to mu s into n. Means Fs is less than or equal to mu s into n. Now what is Fs? Fs is mg less than equal to mu s, but n is what? mv square by r. So this m and this m will get cancelled. Therefore g less than equal to mu s v square by r. Now simply transfer this r and mu s. We will get g into r by mu s less than equal to v square. I can rewrite this as v square greater than equal to gr by mu s. So I will equate this v equal to under root gr by mu s. I am taking maximum condition. So now our third application, vehicle on a bank road. Now consider a road surface is inclined by an angle theta. Then this angle will be said to be angle of inclination. In this road, consider a vehicle of mass m, and the weight of this vehicle acting downward given as mg. Now the normal reaction on acting on this vehicle will be normal to the road surface, and in this case we are neglecting frictional force between the tires and the road surface. So you consider this normal component and weight of the vehicle, and other components are neglected, other forces are neglected. So now we can resolve this normal reaction into two components. First is n cos theta and second n sin theta. Now as we see, this n cos theta and mg are in opposite direction. So this n cos theta will balance the weight of the vehicle. But before that, we will write the forces acting on the vehicle. There are two forces acting on the vehicle. First is weight of the vehicle, and second is normal reaction n. Now this normal reaction n can be resolved into two components. The first is n sin theta. This n sin theta provides centripetal force, and second n cos theta balances weight of vehicle. So we can write n sin theta equals to mv square by r, and m cos theta equals to mg. This is first. This is equation number 2. Now divide equation 1 by equation 2. We will get n sin theta n cos theta equals to mv square by r by mg. By simplifying, we will get tan theta equals to v square by rg. Therefore, v square equals to rg tan theta. Taking square root, v equals to under root rg tan theta.